two topics that we didn't get to cover yesterday. Average rate, which is right here. Notes and examples, and then even odd, which is the next two slides. Notes and then examples. And then once we have all that ready to go, we'll see what questions you had on homework last night up until these two topics. And some of you might have kept going using the examples in the book, and you wouldn't have been that far off, because they're not that crazy hard if you're not that scared of notation, like function notation. And if you know what f of x really means. Slater, well, there might be better ways of doing homework than Slater.
Sometimes, yeah. Sometimes it doesn't help you.
Because it's not very consistent, number one, because they're different people answering, right? And they're answering from their own personal experience, and some of them are, to be honest, levels above you guys as far as their explanations might not even make sense. And then other ones just do it so short and so quick, you're like, I don't know how you got there. Yeah. And then every now and then it's wrong. Awkward.
You can give them only 3 stars on Uber.
Which is why it's really good if you guys come with homework questions, being like, okay, Calc Chat showed me this, but why? That's perfect. I can answer that. Yeah, I can answer that.
I have questions.
Do you guys have questions on 1.5 Calc Chat? Like, you don't understand why?
I don't understand why not.
Okay.
Calc Chat, it basically shows you the word and the answer for the odd numbers.
Oh, it's pretty cool. It hasn't asked you. But they skip steps. All answers. They skip steps that teachers would be able to skip, but that students are going to put one. All right, to that end, let's go ahead and cover these last two topics really fast because we have, you know what I was asking about how your Thursday looked? Because we have our 1.1 to 1.5 quest on Thursday, which we could squeeze into tomorrow if your Thursday is totally packed.
No.
Oh.
No.
We could squeeze it in.
No, we have a WAP.
Oh, there's WAP tomorrow.
Yeah,
We have to learn something on Thursday, and then we have to have like a
We're the majority.
Oh, I have a vocab quest.
Well, you'd have to learn something tomorrow and Thursday, and then have like a longer quest after you get back. That'd be awesome. But if we have a quest on Thursday, what does that mean about our 3.5-day weekend for Honors Pre-Calc?
No homework?
At least not much. At least not much.
Not much.
At least not much. Okay, here we go. Average rate is the exact same thing as what did I write?
Slope.
So, slope, that's no big deal. We've reviewed that this year. Slope is rise over run, change in y over change in x, or y2 minus y1 over x2 minus x1. So why is there a new formula? We've already talked about slope. Rise over run, y2 minus y1 over x2 minus x1. Why the new formula?
Because we're talking about function now.
Well, average rate, yeah, but it's the same thing as slope. So they're giving us a new term. I totally agree with that. Average rate of change is a new term. It's a thing that's found with slope. So in your directions, you're going to actually see the words average rate of change. That's new, but why wouldn't they just tell us that a couple sections ago? Yeah. They're saying, hey, guess what? Now that you've reviewed function notation, what if we just give you the x's and not the y's, instead we give you a function? Now, this example, to be honest, is a lot easier than some other ones might be, because even though they didn't give you the y's right here, what did they give you down here?
The y's.
They gave you the graph, and the graph has the y values, right? So, okay. And this one, is it really that much different, or could you guys have just been like, oh, look, the x is -2 and the y is -2. I know the y. X is -1 and y is +2. I know the y. Like with the graph, if they give it to you, well, then you can just look down and find the y's in the graph. But if they didn't give you the graph, where could you go to look and find the y's? Yeah, the function. Formula. Formula. Howdy, y'all. Okay, so you could take your x's, and if they give you a graph, you can go to the graph and find the y's. But similarly, if you don't have a graph, you can take the x's and go to the equation and find the y's. It's just going to take a little bit longer, right? Now, we could look at this really quickly. We could say, all right, so to find the average rate of change of f of x, as long as you replace or tie together that with slope, right? From the graph, well, technically, we're supposed to do from the graph for letter B, because it says see the figure for letter B. All right, so we're going to do that graphically for letter B. What's it called if we're going to an equation for letter A? We're going to go to the graph for letter B. Algebraically, or you could say analytically. That's like a snazzy way of saying it. We'll just say algebraically. All right, so we're going to do it algebraically for letter A and graphically for letter B. Algebraically. For both of these, slope, you do the exact same formula. y2 minus y1 all over x2 minus x1. For both of these, the exact same formula. y2 minus y1 all over x2 minus x1. But if we're not going to the graph and we're not looking at the y's, we're going to write it a little bit differently. We're going to say f of x2 minus f of x1 all over x2 minus x1. If they don't give us the points and we're not looking to a graph for our y's, well, we're going to have to find them from the function. And the way to find them from the function is by plugging in the x's. How are we doing?
Good.
Need the y's. Have the x's. Let's go find the y's. And the way to find the y's is to plug in. Right? Okay, so what if we come up here and plug in? So what if we wanted to find, which we do, f of negative 1 and f of negative 2? Plug in negative 1, we get negative 1. It's negative 1 cubed. Minus 3 times negative 1 will be plus 3. Yeah? Okay. Or if you plug in negative 2? Negative 8. And then, so we end up with a negative 2 and a 2. Right? So we can come back here and say, sweet. We know what our y's are. The y value at negative 1 is positive 2, and the y value at negative 2 is negative 2. And all we have to do is finish off our formula. Subtracting a negative, we know it's adding a positive, yeah?
Yes.
So mental mathers, what do we get?
4 over 4 over 1.
Ah, 4 over 1, right? So you add, and 4 over 1 would give me an average rate of 4 on the interval from negative 2 to negative 1. Now, double check real quick. We do have a graph. Were we correct in saying that the y value at negative 1 was 2?
Yes.
Yeah. And that the y value at negative 2 was negative 2.
Yes.
Okay, so we were right. But I'm just trying to show you, you didn't need the graph to be able to do that. The function was plenty. Now, for letter B, okay, fine. You have the graph, cool. Go find the y's in the graph. So either way, if they don't give you the y's, they have to give you something to get the y's from. If they just give you the equation, no big deal. There's an algebraic way of doing it. But if they give you a graph, fine. We'll use that. Because to be honest, it's easier. So, for letter B, they say, okay, now go from 0 to 1. So how would you guys set up your formula? F of, why would I say technically 1? X2 minus X1, yeah. Y2 minus Y1. So F of 1 minus F of, what's the other X? But what do we get to do now that I'm allowing you to use the graph? Yeah. So, remember, F of 1 says, what's the Y value when X is?
Negative 2.
1. Yes, Alex, right, negative 2. And then, what's the?
I did something.
0. Ooh, can I ask you guys a different question?
How would you restate F of 0 in, like, the explanation for what we're actually doing, where we're actually looking?
Mid.
Anybody put it in, like, English? The math is F of 0. Sure, I would add one little word. What is the function value when x equals 0, or where x equals 0? So what is f of 0 asking? What's the function value when x is 0? Or another way of saying it is, what's the y when x is 0? But you guys have already know this. It's at the origin. Therefore, the y value is 0 when x is 0. What's my average rate, guys?
Bruh.
Do you need the graph?
No.
No! As long as you have the equation, you'll be fine. Do you need the equation?
Yeah. Yes.
I guess as long as you have the graph, you'll be fine.
You need one or the other.
You need one or the other. Sound good? But isn't the formula the same thing it's been? still y2 minus y1 over x2 minus x1. What's different? You gotta go find the y's. Okay, last topic, even or odd. I think this is where homework ended, if I'm not mistaken. Let me see. Yeah. Even or odd. And I actually want to get another page in here, so let me... I think I have some examples somewhere. Yeah. They're hiding. Okay. All better. Even or odd. New vocab. Just like average rate was new vocab, right? We talked about slope, but average rate of change, well, that's the first for us this year. We've talked about symmetry, but even or odd, well, the vocab's new. Because even or odd only describes functions. Even or odd is specifically for functions. Even or odd is only for functions. But it's still symmetry. What's the what? Well, hold on. What were the original 3 types of symmetry that we talked about originally this year? X-axis, origin, and y-axis. Which of those can a function not have by definition of a function? Because x-axis would fail the what test for a function? Okay. So forget that. Every function will not have x-axis. So what are the other 2? Y-axis and origin. There's new words for me. Or new descriptors. A function that has y-axis symmetry is called even, and a function that has origin symmetry is called odd.
What's the other one? The x-axis.
Help them out. That's this one, right?
Yeah.
But what test does it fail?
Oh, the vertical one test.
So no function will ever have. So even odd, it's the only possible symmetries for function. But remember, even or odd, just because a function can be even or odd doesn't mean it has to be. So we're looking for symmetry, but it's possible a function is neither even nor odd. It has no symmetry. Or it's neither, as far as if the question, well, you guys see the examples on the next page, right? Even or odd. Well, maybe neither. It doesn't have to be even or odd. It just could be even or odd. Now, do you guys remember the test point for y-axis symmetry?
X negative or x.
Remember how we did the test point? No. Didn't we call this an xy? I'm not saying right or wrong, but since everyone wasn't like, oh, I remember it, I'm like, let's think about where it came from. Yeah, if we have an xy and it has y-axis symmetry, what other point would we have? Negative x. Opposite x with the same y. Right? Okay. So we have this test point. Like, it's totally a thing, and we could still use that test point. It just gets a little confusing when we're doing function notation. It gets a little confusing when doing function notation. But can I show you what the test point looks like in function notation? In function notation, if I put a negative x into a function, or if I'm looking for the function value at negative x, well, guys, does anything change with the function value if you have a negative x? So it stays the same. If you plug a negative x into the function, it should stay the same. It shouldn't make a difference whether you plug in a positive or a negative x. So I would put off to the side the same. After simplifying, now remember, it's going to look different originally. You're going to have to maybe like square it or cube it or multiply by something or add something. You're going to have to simplify, but when you plug in a negative x, the y's need to be the same. The function needs to be the same. It needs to mean the exact same thing. So for a function to be even, to have y-axis symmetry, if you plug in a negative x, the y should be the same. But can you remind me of the test point for origin symmetry? Let me start with my xy. Okay, what's the test point for origin symmetry? Negative x, negative y. They both go negative, right? they reflect across the y and across the x. We end up down here in the third quadrant. So think about it. If this one says, give me a negative x, I'll stay the same. What's this one going to tell me if it says, give me a negative x and I'll
change?
And not just change, because, okay, you could change in lots of ways. You could add like an extra number. You could have some like negatives, positives. I need you not just to change, but to be the same value, but opposite. So not just change, but opposite. You guys know whenever you hear opposite in math, what it should be referring to? Reciprocal flips. Opposite makes it the opposite sign. So positive to negative or negative to positive, right? So this one says, okay, plug in a negative x and my function needs to become the opposite. Or it needs to be the same as the opposite of the function. So what I'm trying to show you is the test points still work. They're still a thing. It's just more confusing when you don't have y equals and you have f of x equals. So there's actually like a function f of x way of testing. And the way of testing basically says, only for functions, plug in negative x, simplify. So plug in negative x as your input. Take out all the x's, plug in negative x's in their spot, in their place, in lieu of the positive x that was there. And then simplify. And ask yourself the question. Same? If so, it's even. Opposite? If so, it's odd. Neither? Then it's neither. Plug in negative x, simplify f of negative x, and then ask yourself, is it the same? Got it. Is it opposite? Got it. Is it neither? Now, I believe some of these were homework problems. Am I right? I'm going to make them a little bit bigger. What were the ones that I assigned you guys for homework? Since I want your homework out and open and ready, because we will go over questions as to how far you got last night. 75 and 71 are the ones you guys did have?
75, 76, the same focus
You would think. You see it? 3 over 2 versus 2 over 3. Okay. Since 71 and 75 are odds, and since you have calc chat in the back of the book to check, I'm going to go over some evens. So I don't want to take away all your practice. That's no fun. And you wouldn't know the answers to the evens if you were to want further practice before your quiz, right? So on number 72, let's say we were testing number 72, where I have g of x is equal to x cubed minus 5x. What does my symmetry test, my even odd test, tell me to do? So if I plug in, would you guys legally plug in function notation and get negative x cubed minus 5 times negative x? But after you legally plug in, now we have to ask ourselves the question, same, opposite, neither. Oh, wait. What should we do first? Simplify. Okay, so simplify. Yeah, a negative cubed is going to stay negative, right? That one's going to change to be... Hold on. It's not the same.
No,
Is it neither or opposite?
it's neither.
Oh, because he's negative and he's positive. Wait, everything's switched. Everything's switched? How can you check to see if it's opposite?
Backwards.
Because if you pull out, wouldn't it be x cubed minus 5x? It looks like neither because it's like, it's changing all sorts of stuff. But wait, if I pull out a negative, didn't it just make the original opposite? So g of negative x equals negative g of x. That means this has what type of symmetry?
Odd.
Well, good. We can describe the function as odd, which means it has order symmetry.
Is there a way to say, like, if you look at the degree of it, like, if you look at the first exponent, it's termed as one as odd or even?
I wish. Can I show you a counterexample? So what if instead of that one, what if we had, you guys hear what Emily's question was? It was a really good one. She noticed this had an odd degree. She was like, oh sweet, so aren't they all going to be odd as long as the highest degree is odd? What if I was to do x cubed minus 5x plus 1? So we went to test, right? Would this turn to be opposite?
Yes.
Yes. Would this turn to be opposite? I was doing this. Yes. Would this? Oh, that's a neither. Because opposite, same. If I pulled out a negative, I would get, okay, that's a negative, an x cubed, I would get, okay, minus 5x. Is that the exact same as the original but opposite?
No.
Neither. Now, this function, wherever he is going to look like origin symmetry, but guess what's happened?
Ew.
It's been shifted. No, it hasn't been shifted like that because it's not even. But it's been shifted probably something.
But if it is like, if it is
Just with-
even or odd without determining neither, can it still be with the highest degree?
This function would never be even because it's a cubic.
Yeah.
It could be odd, but you have to test it. Does that make sense? This one could never be odd because it's a 6, but it could be even.
So you can find out it's even and neither odd. It's not even.
So the highest degree does tell you which symmetry it might have if it's specially centered around the axis. Yeah. Can we go back to this one? Okay, that was number 72. How about number 74? Ooh, let's use Emily's trick. So, what degree does this have for us to start testing? Exactly, it has a square root. So the trick is cool to say even or neither, odd or neither, but we have to still check if we see the highest degree. But as soon as we get to weird functions, that kind of just flies out the window. So instead, let's just test. And the nice thing is for these ones, you don't have to do 3 different test points. Well, x-axis symmetry would never be true. 2 different test points. You do the same thing and just ask yourself a question to analyze what you get. So for number 74, we're doing what we would do even if we thought odd, even if we had like a hypothesis. Well, it doesn't matter. Just plug in the negative x and see what happens. So if I plug in a negative x, guys, what do you get? Yeah, negative x. Square root of negative x plus 5. Why neither? Yeah. This would make the whole thing opposite if that was the only change, right? Because that would have made the entire multiplication the opposite sign. But the problem is he changed too, and he didn't change. So even if you tried to make this look a little different, and like pull out that negative and say, well, maybe, well, that changed it. And then if you even tried to pull that negative outside, well, that's kind of illegal because of imaginary numbers. You're going to have some issues. Long story short, that made it all opposite until all this inside stuff started changing too. Yep, this is going to be a neither. Neither even nor odd. If it was just the outside, it would have been great. But since this changed and that didn't, and even if they had both changed, I can't pull him out. That's a neither. Now, could you always go back to the test point idea and try the test points if you got confused? Yeah. You could make him a big old y and then try plugging in your negative x positive y, negative x negative y. But neither of those would work either. How about number 74? Sorry, 76. No one knows evolution anymore. The movie's too old. Al, you don't know that one, do you? You don't have them. Do you know the song 76 Trombones?
No.
It's a movie and a play. It's called The Music Man. Whenever I say 76, a song pops in my head. But
69.
sure. Not for me. All right. I'm worried because of that 2/3. Any of you guys worried because of the 2/3?
Yes, I'm very worried.
Some of you are like, nah, I got that. The rest of you are like,
Why should I be worried?
what does 2/3 mean? Because you need to simplify this or else you don't know, right?
Oh, I remember. Mr.
Yeah, it's a
Cherry.
cube group.
Oh, yeah, I remember.
My dad, Mr. Cherry.
I get it.
Don't we have a 4 on the outside? But what else is going on? How'd you remember that?
Because of Papa Shay.
Okay, how? What did he teach you?
Yeah, you're talking math. That's pretty much it.
He didn't give you a way of remembering?
Just math.
He just called everyone twice.
And so you were like,
Cherry dog.
anyway, I think of it as negative s squared.
He abandoned us.
He wouldn't have been teaching on his own. He would have been stuck with me.
So much easier.
But he would be here. You won't say hi to Mr. Cherry. Yeah.
You can go over to Mr. Graff and be like, I used to love to come in this room.
No, that's a totally different
He is nice.
It's a different vibe.
It is a different vibe. It definitely is. But you can use that as like an intro to be like, I loved my math class last year. And then you can like, how are you? I would love to love you too. There you go.
Mr. Cherry was not like that. What's Cherry's? No.
Mr. Cherry's not from
Cube group. How do you know?
We should have one.
Although he has quite a long commute, he might not be able to make it back.
I don't have a
In
link.
this Volkswagen.
Mr. Che might be there Wednesday too. Mrs. Regan and Mr. Che.
Let's go.
It's until 8 o'clock. Well, I don't, Mrs. Regan won't be there till 8 o'clock.
Oh, it's a Chick-fil-A?
I know, because of
I can't go. I have to do work.
Hey.
Mr. Cherry
Decline, don't stop with Mr. Hamilton.
Daddy
Daddy
There you go,
Trash.
Yemen.
That's his name now. We're calling him Daddy Trash.
Question. What ends up happening? Back to the actual, problem we're supposed to do. But good job with the 2/3. I'm so proud. Yes, it's squared underneath the cube root. But what ends up happening?
It gets back to a positive end.
Oh, it does? Because the negative squared is a positive? Which means it stays the
Same.
And if it stays the same, what do we get to say?
It's awesome.
Careful. Awesome makes me think of odd. And that would be the wrong answer.
What is awesome?
Oh.
Because like odd makes me think of origin because they both start with O. And so then like awesome, odd.
Awesome.
I don't know why awesome would make me think of either. Oh.
Awesome.
Questions on plugging in negatives and figuring out evens or odds? Or neither. Remember, neither is an option.
Austin is I'm still subscribed.
Hey guys, we're checking out another one we haven't checked out yet. 73. What do you think? Well, what's going on?
I was doing something sounding right now.
Just because of it square.
Right? It just makes you like, ugh. Okay, help me out, keep me honest. So I'm going to change the page and forget the function. What if we're testing 73? It's an F, right? F of X. X times the square root of, oh, I remembered it. Okay. Alright guys, step 1. Plug in carefully. But simplify. What's different with 73 than the other square root weird one, 74?
There's already a negative.
This stays the
Same.
wait, but this changes. Oh, it's neither stayed the same and then it changes. Up, it didn't all do. Wait, couldn't I separate this legally to be? Isn't that true? Because there's no plus or minus. this doesn't get distributed. It's actually a negative to the entire product. Like negative 2 times 3 would be 2 times 3 with a negative. I could multiply and then the negative. There's no distribution. So actually,
Have the actual negative number.
yeah.
And then
It's the same with an opposite. Where? Oh, sorry. Understood one. I separated it. Yes. Because I could separate this to be negative 1 times 5, and I'm not wrong. I just made it look weird.
But isn't it like your opposite though, just because negative?
Oh, but remember, opposite means changing the sign. 1 doesn't change the value. Negative changes the sign. So multiplying by a negative 1 is making it opposite.
What if we don't think for like so very good?
Well,
We get it wrong.
then,
Small brain.
well, that's the problem, right? You could get it wrong because you're like, I don't see it.
Small
Okay,
brain.
then ask yourself the question. It's not the same. Like, it's not even. We know that for sure. It's between odd and neither, right? Okay, if it's odd, it would need to match with negative f of x. That would be my hypothesis. I'm like, okay, if it's odd, it needs to be this. Couldn't you take that and plug in and say, okay, does it match? Right? Is this the same as that? That's the question, right? So you have to ask yourself, does this negative, wait, doesn't parentheses just mean times? Like that times that times that? Isn't that what I have? That times that times that. So the reason I pulled the negative 1 out is just to show you it's just good old-fashioned multiplication. So I could make this negative 1 times x times the square root of 1, which is the exact same thing as negative 1 times x times the square root of 1. They are the same.
Confusion.
So why did you do that?
Because 74, I could have separated that negative the exact same way. But the dilemma in 74 is that if I had separated the negative, which ended up being like here, I could have separated the negative, but the problem is the underneath would have been different. And if I tried to factor it out, well, that's still different, and I can't pull it out of the square root. So I was stuck. I couldn't like resolve the issue. But yeah, I could have done the same thing. It's like opposite, but that changed. So it wasn't just opposite. But yeah, super similar. This one stayed the same with an opposite. Cool, opposite. This one, opposite, and it changed. Cool. Okay, we got to the end of section 1.5. True? If I were you guys, before we go over homework questions that you guys had up to average rate of change and even odd symmetries, you might want to take a quick picture or write it down, either way. Because these are the things that you guys might want to start reviewing tonight. If I was an amazing honors teacher, I'd probably have the quiz tomorrow and be like, good luck, have fun. But technically, some of you still might need to finish up the average rate questions and the even odd questions for us to go over tomorrow. And I guess it might be nice to have some sample problems to review section 1.1 to 1.5, yeah?
Yes.
All right, so we'll go a little bit slower. Because you guys all checked it the first time. A few people did, just not everyone. However, does anybody have any questions they know already on homework? They're like, please, can you show me how this works? Sophia, you had one.
Yeah.
Do you know which one?
Me? Yeah. 15.
15. Are there some other questions, though? I saw some other hands. Yeah. 20. 60. 7? Okay, let's start with 7. So on number 7, he's kind of funny because there's lots of information, and it's asking for lots of things. And it says, use the graph of the function to find the domain and range. Now, hold on. So they put little points to stop it.
Yes.
Okay. The answer is no. They didn't put like clear little points, but I know some of you thought it stopped, so that's going to mess you up. But this actually keeps going if they don't actually put a point, like an obvious little filled-in circle or hole. They mean keep going. So they're saying use a graph of the function to find the domain and range and the indicated function values. Domain and range and the indicated function values. Megan, was there like a specific part of it that you didn't like, or was it like whole?
I think it was just finding.
Okay, because these ones you could estimate, right? Like go to x's and then estimate the y's. But domain and range, you have to ask the question, how far left to how far right? You actually, for how far left, the answer is going to be negative infinity because it's going to keep on going outwards, which is hard because you might not have realized it kept going. So the domain, negative infinity to similar logic, positive infinity. But range, how low does it go?
Like 4?
Yeah. Negative 4-ish or negative 3.8-ish or something, right? I would say negative 4-ish to positive infinity. Does that make sense? Yeah. So you guys, careful. Just because the book stops it, I guess they should have showed little arrows, but at this level, they're like, you should know it keeps going. That's kind of nasty. Somebody had a question on number 10. Is that right? I know we had a question on 15 and then 20. No 10? Okay, 15. And then 20, we're in a similar section, and they were talking about the zeros. Why do you think people didn't like 15 or 20 if the directions were find the zeros? Yeah, because you had to factor. No. You had to factor, right? So for 15 and 20, you had to set... I don't even know. For 15 and 20, you have to set equal to 0 and factor. I give up. Highlighter? Somebody?
Let's just go for a moment.
Okay, what if I just go over here? And what if I just... Close it up. For number 15, your modified x method, you would have to do negative 60 and negative 7. Do you guys think about 12 and 5? But remember, you have to go ahead and do the grouping method, because these are x terms. And you're looking for what's in common and what's in common, right? But for number 20, he's even weirder because... But you take out the x squared first, right? And then you would have 9x squared minus 25. And then it's a difference of squares. So it's weird because it wasn't a trinomial, but you can still... And remember, set each one equal to 0. Now, hold on. X squared will only be 0 if x is 0, right? Some people get confused on this one because it just looks so different. But guys, you can plus or minus square root, but that will only happen if x is 0. So these ones are a little bit more normal, negative 5/3, positive 5/3, and then this one will only if x is 0. Up here, you would do your grouping of, and if all is right in the world, which isn't always necessarily true.
It's never true.
Never true? Oh, fun. It sometimes feels kind of true. These should match, which they do, and so what matches is the x minus 6, and we have 2x plus 5. And similarly, you're going to need to set everybody equal to 0. Does that kind of make sense, my 15, 20 people? Okay. There was a question on number 60? Yep. What were the directions on that one? What were you doing?
You have to graph it, and then determine which variables f of x is greater than or equal to 0.
Ooh. But in graphing the function, oh, I see. They didn't say you could use your graphing calculator. Was that where it got tricky?
Yeah. I use my calculator.
Well, if you did, I would actually let you use your calculator because we haven't reviewed all the different functions and translations and dilations and reflections. We haven't reviewed all that. So I would have actually let you use your calculator. And if you... Okay, fine, forget it. If you... some key points that he hit? Upside down V, good. Okay. It was like that-ish?
Upside down.
Oh, upside down V. Because he got reflected, that's good. Oh.
Bruh.
Strong. Like that?
Yeah.
Cool. Hey guys, what is it saying if it says f of x is greater than or equal to 0? F of x means the same thing as y's, which are the same thing as the heights. And greater than or equal to 0 means positive, right? So it's saying, where are the y values positive? It doesn't even hit 0, let alone the positives, right? Does it hit any of those? So therefore, yeah, so therefore, all right, any other homework ones I missed? I think I got most of them. Oh, right here. 52. 52 is saying, use a graphing utility to graph the function and approximate any relative minima or maxima. I can give you a hint on the calculator as to where to go. Now, you're going to have to play with your window to see it, but I think Zoom Standard should... Oh, that 15. You might need to zoom out to see it. But when you go to your calculator, can I make it big? You're going to want to go to that y equals to throw in the function. You're going to want to throw in the function, let me save it just because of time. Pause. But second trace gets you to that really cool menu where there is a minimum and a maximum. That's the feature you want to use. And I'm guessing it's one of these dudes where there's a maximum here and a minimum here. See if you can get your calculator to find it. But we'll go over questions tomorrow. Alright guys, start studying. Maybe even tutor some pre-cal kids. They're a little bit behind you guys and they have a quiz.
Can I tutor my brother? Does that count? He's in algebra 1.
Yeah. I don't know if they need you tutoring this week.
Oh, there's a piece of baby over here. Bread.
That's expensive.